Good morning, everyone. My name's Tony, and today I want to talk about vision sensors. Now, it's just a term. Vision systems have been around for a long time, and you'll hear different terms from time to time, and right now the new term is vision sensors. We've all heard what a smart camera is, and the big characteristic of a smart camera is everything is in one package. So you've got your lens and your light, and everything is in one box, where some vision systems will be a two-piece system or a three-piece system where maybe you have a giggy camera and you're going back to a controller or going back to a PC with a frame grabber and so forth. But back in the 90s, they consolidated everything into one package and they called it a smart camera. And of course, everybody makes them. All the major manufacturers out there have some version of a smart camera. And then a few years back, the term vision sensor started being coined a little bit more. And so I wanted to explain exactly what we're seeing when we see the term vision sensors. Mainly, it's still everything in one box like a smart camera, and the image that you see up here on the screen right now is a depiction of a vision sensor. So we have the camera body, and one of the primary characteristics is that they use these small M12 lenses. They're very inexpensive lenses. They come in different focal lengths. M12 is just the size of the lens, and then sometimes it's referred to as a micro lens. And so most vision sensors out there, regardless of the manufacturer, uses some form of these M12 lenses. Another characteristic is the internal ring light. There'll be an internal ring light around these M12 lenses. M12 lenses are very small in diameter, which allows for us to put a ring light, an integrated ring light, right on the sensor itself. Where with a smart camera, although there are some that do have integrated lights, they use C-mount lenses, which are a little bit larger, which usually prevents you from putting a ring light right on the face of the camera. So vision sensors are using these M12 lenses. There is an internal ring light on there. And then there's a cover, which is actually used to focus that lens. On a C-mount lens, you would turn the lens itself or a setting on the lens to either set an aperture or get a focus or so forth. Here, when you screw the M12 lens into the vision sensor, you put it in there all the way until it bottoms out. And then there's some type of cover on the front that actually moves the board that the lens is mounted to. It moves the light and the lens. That board will move in and out as this focus cover is turned. Of course, there's an O-ring on here, so most of these vision sensors are IP67 at least, especially when you plug up all the ports on the bottom. So the three major characteristics of a vision sensor is it's all in one package. It uses an M12 lens with an internal or integrated ring light. What I'm going to talk about today is we have two manufacturers that we represent here at C&E Sales, Banner Engineering, which has both smart cameras. Matter of fact, they do have a new one that just came out last year. And of course, what you see on the left side of the screen here is the Banner iView sensor, which has gone through a number of iterations over the past 6 or 7 years. That's actually been out a while. It was one of the first vision sensors out there. And then of course, Teledyne Dalsa, who's been making cameras for a number of years. And of course, they jumped into the smart camera market probably 8-9 years ago. And then the vision sensor market, which is what you see here on the right-hand side of the screen, they came out with that just last year. So they were a little late to market on that one, but they realized everybody's making these things called vision sensors, and they wanted to get in on the act. Another characteristic of a vision sensor, though, is the fact that they're usually simpler to program. Some are still using a software package, but others are actually being programmed right on the sensor themselves. And I'm going to start today by talking about the Banner iView, and here's some characteristics of it. And you'll notice that the name up there is iView 2 Plus Gen 2. So that just indicates that they've gone through a number of iterations of this sensor. The original was just called the iView. Then they came out with the iView Plus, and then they came out with the iView 2, and now there's a Generation 2 and so forth. But they're basically firmware upgrades or tool upgrades and things like that. So what we have inside the iView is, and I'm just going to refer to it as an iView. There are 4 software tools on board, and I'll get into each one of those a little bit later. You can store up to 30 programs inside the camera. When these things first came out, they only had 1 program, and so you can only keep 1 program in there at a time. So this is one of the improvements that they've made. The way this system is programmed is through touchscreen programming. And there's two ways to do that, which I'll show you in the next slide. There's one size imager in the Banner iView product line. It's a 752 by 480, which is essentially a 640 by 480 CMOS imager. That's another thing you'll see a lot in vision sensors. They've stepped away from CCD imagers, they were very prevalent in the 90s and the early 2000s, to the CMOS imagers, which are much less expensive to produce, which allows them to bring the price of these devices down quite a bit. Even though it's programmed via a touchscreen, the iView does come with emulation software so that you can practice using it on your PC without actually being connected to a sensor. And later here in this presentation, I'm going to open up a couple of examples of where I've used the iView in the real world, and I'll be doing that using the emulation software. There is industrial Ethernet on board. We do have Ethernet IP and Modbus for this. There are a couple other smaller protocols, but those are the two big ones. Banner is now just starting to put Profinet on. They put it on their smart camera that came out last year. Whether it's going to migrate down to this product, it's yet to be determined. There's a USB port on this, mainly used for taking images off of the iView or upgrading the firmware to the iView. Banner offers free firmware upgrades. You can download them from their website whenever they make some improvements, and you just have to download it, put it on a USB stick, and then there's a dongle that plugs into this camera, and this is how we get the firmware upgrades on here. Because this unit never really directly connects to a PC, although it does have Ethernet, but really it's just used for exchanging information through Ethernet IP. There's really no programming through the Ethernet cable. All the programming is going to be done with the touchscreen. This unit does have 3 discrete outputs, and you can program them to be either NPN or PNP, normally open, normally closed, so forth. And there are barcode models of this unit. And most imager-based systems, whether they're smart cameras or vision sensors, because you have an imager on board, most of them have versions of barcode reading. QR codes, data matrix codes, those types of things need an imager to read them anyways. And so they're kind of already self-suited to become barcode readers. And they do have barcode reading models. 2 ways to program the iView. The original way was what we call the TG, the touch grayscale, where the screen, there's a little small touch screen right on the back of the unit, and all the programming would be done via that touch screen. And then they came out with a remote grayscale unit, because sometimes you're putting these sensors in areas where it's difficult to get to the back of the unit, and so the remote display can really be useful in that scenario. The other thing too is if you're using multiples of these, when you get the remote unit without the screen on the back, it does have a lower cost to it. Of course, then you have to buy the display, which has a little higher cost. But if you're using multiple units, you can just have one display and just move it from unit to unit to unit to program these things, because once they're programmed, they're usually, it's a walk away and let it go. And so you can save money, in that scenario. This is just a picture of the bottom of the unit. This is my demo unit. And on the left, you see an 8-pin M12, which is used to connect to a remote screen, which is my model is a remote screen. There's a 12-pin male M12 on the right, which is for power and I/O. And then the 2 ports down on the bottom, those are M8s. One is for the USB and one is for the Ethernet. And let me just go to the next slide because it will label those a little bit better. So if you get the unit with the touchscreen right on the back, you're not going to have connector A on that model. And so you'll just have the other 3. These are the M12 lenses. They have 6 different choices in M12, and they do offer a C-mount version of the iView. A lot of the vision sensors that are out there, regardless of the manufacturer, do offer a C-mount model. Now, what you usually lose when you go to a C-mount is the C-mount is a much larger diameter lens, and so you don't have the internal ring light anymore. So you're going to be using external lighting with it. And in many scenarios, you may be using external lighting anyways. When you have a ring light built into a sensor, you're going to be perpendicular to your target with your energy from the light. And a lot of times that can create glares and things like that. So you may have to change the geometry of the sensor in order to get the contrast or the image that you're really looking for. Sometimes you have to put the camera perpendicular to your target based on your application. And so the internal ring light may not be the best choice. And so you may go to some external lighting source anyways. And in that case, sometimes people will go to the C-mount. But 95+% of the time, we're using an eye view, we are using the M12 lenses with the integral lighting. These are the 4 tools that are in the eye view. The original tool, of course, is the match tool, and it's a pattern algorithm. It's a very strong pattern algorithm that Banner designed. Matter of fact, it was such a good tool that when they came out with their smart camera last year, Banner actually moved the match tool and this blemish tool that you see down below into their new VE smart camera product, because they were both very strong algorithms, and they made a good match for, no pun intended there, for the VE smart camera. But the match tool in here works very well. It's 360-degree pattern match. The area tool, which is really a blob tool, if you're familiar with vision terms, it's a blob tool. You're counting light and dark pixels and so forth. And I can show you an example of that when we get to that phase. The blemish tool really is just it's a good edge extracting tool. And their algorithm is so strong that you can have changing ambient light conditions, and it still pulls those edges out. A lot of times when you're using edge-based tools, if you have a change in lighting conditions or in contrast, the thresholding of that edge tool it may stop functioning, and so you may not find the edges that you want. But the blemish tool can find edges over a large range of changing ambient light conditions. I use it a lot to look for labels. If you've got a product that has a label on it, but the label changes a lot, or from run to run, instead of teaching it individual patterns, you can just teach it the artwork on a label is going to have a lot of edges to it, and so you're going to get a large number of edges when there's a label there. And then when the label's missing, the number of edges that the blemish tool would see would decrease by quite a bit. And so you can do pass-fail label detection with a blemish tool. It was created to look for scratches and mars and things like that in surfaces of your products, but I find myself using it as a label detector more often than not. The sort tool is really just a match tool that allows you to store up to 10 different patterns in the tool. And since there are 3 discrete I/O points in the eye view sensor, say you just had 3 patterns, you can actually fire a discrete output based on which of the 3 patterns that it sees. Of course, via Ethernet communications, say you had more than 3 patterns, you had maybe 5 or 10, you could actually load that into the register of the PLC as to which pattern that it saw, and so you can do some some sorting and some selecting with that tool. And just to give you a basic price range, the Vision version of the iView is around $1,500, and the barcode version of that is around $1,600. And of course, there's variations depending on whether you get the one. These prices are for the one with a screen built into the back of the sensor. If you get a remote screen, then things are going to change up a little bit for that reason. So with that, I'm going to back out of this, minimize it, and I'm going to open up the emulator software. And first, I'm going to show you, and I'm going to build these applications right in front of you. It's not going to take long, but I find if I have just canned applications and I just show you that it automatically works, it's a little less believable than if I actually build it and maybe even make a mistake or two while I'm going through these menus, so that you can see, what you actually have to do when you do this yourselves. This was it's a rubber washer. The white areas that you see here were flat areas, and the dark areas were beveled areas. So when the light came out of the eye view, it was perpendicular to the part, and it went down onto the part. The beveled areas sent the light off in some other direction. That's why they appear dark. And then the bright areas were flat and perpendicular to the lens and the light on the eye view. And so that energy came straight back up, and it looked bright. Of course, it created a nice highly contrast target. And so this was a washer. This was one side, and this was the other. And the application was to determine these were coming down a track. They were coming out of a bowl feeder, coming down a track, and they just wanted to know, when it was right side up or upside down. And of course, they just kick them back into the bowl and come around again. So we were just sorting these for orientation purposes. And so what I'm going to do is I'm going to just open this up. And I've got a couple of pictures in here. And of course, this thing moved around a little bit. And so as I go through these images, they're not always in the same position on the conveyor. And there's the ones that are flipped up the other way. I don't know I can't remember which one was right side up or upside down. But I just need to distinguish between the two of them. So we're going to go to this one. And I'm going to start to build this. And since there's a little bit of movement in this part, I'm going to use a couple of locators that we have in the iView. Now the locators only work with the area tool, which was really a blob tool. And I want to use the blob tool because I've got this nice big dark ring in the middle. And if I look for dark pixels, that will become a dark blob. And when, of course, it's flipped over the other way, that you don't have this much dark area in here. And so I'm going to set this application up with a blob tool so that we can determine orientation. So let's go into the menu, and I'll go into the inspection. Let's go into the sensors. And right now there's already an area tool selected. But I do want to come back out and go to Properties, Motion, which are really locators. And I'm going to enable my motion. And it's going to put two locators on there. And these are just edge-based locators. And you can have either just one or you can have two. I'm going to use both of them this time. And so now I'm going to come back out here to the main menu. And I'm going to click on this first locator. And I'm going to shorten that up a little bit. There's not a lot of movement in this. I'll go to Edge 2, and of course it's labeling these right up at the top. And I'm going to just come up here and just find that top edge. And then I'm going to come over here to my blob tool. And the blob tools have different shapes. Let me go back in here and at least show you that. So if we go to Sensors, we go to Area, and you're going to hear me refer to it as a blob tool. We can go to ROI, which is Region of Interest Type, and we have a circle, we have a rectangle, and we have an ellipse. And I've already got the circle selected here, which is what I'm going to use because we do have a round target in the middle. And so I'm going to come all the way back out to the main menu, and then one more. And I'm just going to click on my area tool. I'm going to move it up here. I'll make it a little larger first. I'm going to move it up here, and I want to encompass this dark area in here. And now I'm going to go back into my main menu and into my inspection menu, Sensors, Area. And there's really a couple of different settings in here. There's an intensity range, and of course this is grayscale down here on this graph on the bottom. We've got 0, which is black, 255, which is white, and it's showing us, you know, what the different pixels are inside this region of interest, this circular region of interest. And of course, if I grab this bracket here and I move it down, you know, now these pixels really aren't black; they're more of a mid-gray. And so the reason that disappeared is because the grayscale of these pixels is actually in here somewhere. And so if I drag this bracket back out, you can see I'm starting to pick them up. And it's usually somewhere right around the break anyways, because we got a large white area around it. And so now I can see that I'm finding the dark pixels that I wanted just by setting this intensity range. I also want to go in here and look at the area range. I'm going to want to see a certain number of dark pixels. And so I've got two brackets up here, and as long as the number of dark pixels falls in between these brackets, which is what this little green square is, excuse me, we're going to be able to pass or fail this. And if I go to my pass count, I need to see a minimum of one blob of that particular size and intensity, and a maximum of one blob of that intensity and size. So let's go to Run. And this little camera icon down here in the right-hand corner is like a trigger. So as I click this, it's going to go through the different iterations. And then, of course, when it's flipped on the other side, this red X up here at the top is telling me that this part failed. Now, I could have taught it this side so that this one would have passed and the other one would have failed, but I don't remember which one they actually wanted to see. And so as I go through this, they're all failing. And of course, when it's the right orientation, they're all passing. And that's how I set that up. When I go to the run and I start looking at the real situation, one of the things I like to do is go into my inspection menu, Sensors, Area Tool, and I like to look at the area range. I like to keep that graph up while I'm testing it. And so now as I go through these different iterations, I want to make sure that this square stays inside that bracket. You see I picked up a small yellow one down here. There's probably some dark pixels that crept into the edge of this tool somewhere, and that's what's showing down here. But when I get to the part that's in the wrong orientation, I come outside of this bracket. I'm close. You know, there's a lot of dark pixels right in here, but I fell below my lower bracket, and so that's why this part failed. And you can see the locators actually keep this circle area tool right where it needs to be on the part. You can see the parts moving around, and those locators are moving that tool accordingly. So that's one example. I'm going to close out of that right now. And let's do one more example. I'm going to go to this weld nut. This is a picture of my setup. And so this is at my lab. And there was a metal bracket, and it had a weld nut in the middle, and they wanted to make sure that the weld nut was there. So it's a steel weld nut on a steel bracket, and so the contrast was very, very low. I mean, they were the same contrast between the nut and the background. Here's my eye view sensor here. And so instead of using the light in the unit, here's one where I actually used a banner spotlight, and I put it at the same angle of incidence as the camera. So this angle right here is the same. And what that did for me is it created some nice contrast for me. So here's what the weld nut looks like. And of course, it was a square weld nut, but it could be in any orientation. They didn't really care about that. They just want to know that it was right side up versus upside down. So as I go through these images, you'll see that the orientation will change here as far as its rotation. But when it's upside down, we get a much different look to this. And of course, that can be in any orientation. And of course, they also want to know when there was no weld nut there at all. And so those are my conditions. So if I open up this emulator, what I'm going to do here, I'm going to blow this up so you guys can see this a little bit better. I'm going to put a match tool on here. Because of the way I had the light, I got a nice bright ring on the top of this weld nut regardless of its orientation. If I go through these pictures in here, you'll see that pattern stays very much the same. But then when it's upside down, we don't get that. And of course, when it's not there, we don't get it at all. So I'm going to use this nice shape to my advantage because of the way I put the light geometry. And so here, we're going to go back into the main menu, and we are going to go to sensors. And right now I've got an area tool selected, which I don't want to use. I'm going to use a match tool for this. And so I'm going to add a sensor. I want to minimize this a little bit. It just makes a little more sense here for me. So I'm going to add a match sensor, and you can have multiple sensors in your inspection at the same time. There are limits to that. They're all memory based. The sort tool is the only one where you can only have one because it does take a lot of memory. And so since I'm going to use a match tool, I really don't need the area tool. I'm just going to hit that pull down arrow, and I'm going to delete that one. And now we'll go back to the main menu. And here's my match tool. And so what I'm going to do is I'm going to, first of all, I'm going to come back off of that. And I want to get this more squared up picture for putting the match tool on here. Just makes life a little easier for me. And so I'm going to put this match tool just around this area that I've created with my light geometry. And I really only need to see about half of that to really get a good pattern. And at that point, I just hit teach. And I've taught that pattern. At this stage of the game, I think I'm really done. So if we just go through these targets, that one passed. The screen check in the upper left-hand corner is passed. And you can see, regardless of its rotational value, I'm still passing this because that light's creating this nice little arc ring down here. And then, of course, when it gets upside down, see, it's still looking for that pattern now, but it's not there, and so this failed. And that's why it turned red. And of course, when it's not there at all, we don't see that pattern. So once again, I'm going to go back into my inspection area, and I want to pull up that graph for the match tool. And the one I want to look at is percent match. And of course, this is my threshold. So as long as my pattern falls above it, I'm going to pass it. And now we can watch how it's going to act. That's the one I actually taught it on. That's why it's right at 100%. And they're really staying up there nice and high. And now this is, it sees some white in there, but it just doesn't match that pattern enough. But it got pretty close to my threshold, so maybe I take my threshold up here to 75. And go through these, all those fail, and then this one passes. And so that's just one way to use this to solve a weld nut issue. And I come across weld nut applications quite a bit. And of course, sometimes you can rarely get straight over the top of a weld nut because there's usually a process just before we inspect that's actually putting the weld nut on there and staking it. So that's that. Let me go back to my PowerPoint. We'll go in here, and that's it for the banner product. That was the banner eye view. And so now what I'm going to talk about is the Teledyne Dalsa vision sensor. While I'm thinking of it, the eye view is monochrome only. They did not come out with a color version of that, and I don't anticipate that they will. When the BOA Spot came out, which was early last year, I believed it was going to be a monochrome sensor only too, but I just found out about 2 weeks ago that they are planning on coming out with a color version of the BOA Spot. And so we should see that maybe in the next month or so. So we'll be able to maybe do something with a vision sensor that actually has color. And of course, the BOA Spot uses iInspect Express. The BOA, which is Teledyne Dalsa's smart camera, that's been out for about 8 years or so. It's been a very popular sensor for us. We've sold quite a few of those, solved quite a few applications with that product. It's very powerful. And so when they came out with their vision sensor and called it the BOA Spot, they took a lot of the algorithms that were already in the BOA and just migrated them down to this platform. And they actually used basically the same software, which is called iInspect Express, but they changed the GUI a little bit to make it more intuitive. I really like it. I suspect that over the next year or so, they will migrate that GUI back upward into the BOA Smart Camera product because a lot of customers really like the way the GUI works in the BOA Spot. It's very intuitive, very simple to step through, and so I expect to see something like that happen. Here's some features. The BOA Spot has the software built into it, so it is a web server-based software. You type in the IP address, the camera loads some files onto your PC, and you have to use Internet Explorer to talk to this right now because they are using some DLLs, and that's how you program it. It does have image pre-processing. For those of you who know what that is, it's dilate erosion. They've got some Sobel type filters and things like that in there, convolution filters and so forth, which is kind of a powerful thing to see in a vision sensor. You see that in smart cameras, tends to take the price up a little bit higher. But they brought the image preprocessors down to the Spot, and they also brought a full C+ script editor down to the Spot. So we do have a script tool in here to do some logic. Again, IP67, much like the iView was. The industrial protocols in here are Ethernet IP, Modbus, TCP, and we do have Profinet on board. We are a Siemens distributor, and so Profinet comes in handy for us for that. There is PC emulation software included with the system. Although the software is built into the camera, we do have emulation software. I want to point out right now that when customers get this system, there's a CD with it, and of course the first thing they do is pop the CD in, load the emulation software. They open up the emulation software and expect to see what the camera sees, and they're different. To get into the camera, we have to use Internet Explorer and just go in through the web server to get to the images that you're going to see on the camera. So just want to point that out. I've had a number of customers get that confused, and so I thought I'd take this opportunity to point it out. And again, they have a reader version of this product as well. The Vision came out, and then the Reader came out. The Reader algorithm in the Spot is extremely powerful. They actually purchased that algorithm, and I'm not sure who they purchased it from, but it's a really strong and fast barcode reading algorithm. They've actually migrated it back up to some of their older products. There are two resolutions of the BOA Spot, the standard 640-480, and they do have a 1280 by 960. FYI, if you are going to read linear barcodes with a Spot, and they are long linear barcodes, like a code 128 or a code 39, I highly recommend you step up to the 128 by 960. The extra pixels make reading those longer linear barcodes much easier. And there's a 1 gigahertz processor on board. There are different versions of software built into this. We have, for the Vision model, we do have an SL, which has 6 tools in it. And they're some of the most popular tools. You've got the match algorithm. They call this the count tool. It's really a blob tool. You know, Banner called their blob tool an area tool. Teledyne Dalsa calls their blob tool a count tool. Hopefully someday in the future everybody will call a blob tool for what it is. It's a blob tool. We do have edge count. We do have some grayscale tools. We do have a caliper measuring capability in the SL. But if you do need a few more tools, there you can step up to the EL, which gives us some more measurement type tools here, some angular tools, arc tools, and some circular tools, which can be very helpful in a lot of situations. In the reader models, we have, again, 2 levels. You have the IDS, which has linear barcodes, data matrix barcodes, which cover ECC 200s, QR codes, just about all the different codes out there. We do have some preprocessors that we can preprocess the codes with before the tools read them. They did put a blob tool in here and a point tool, which is used for some positioning and things like that. Or you can step up to IDE. The biggest deal here when you step up to the IDE is you also get a match tool and you get an OCR tool, optical character recognition. So if you are going to do some optical character stuff, you will use one of the reader models, but you do have to step up to the IDE. The nice thing is if you get an IDS and then at some point down the line you would like to have some of these other capabilities, it's just a firmware upgrade. We get the Mac ID from your sensor. I think it's a $400 upgrade to go to this software, but you wouldn't necessarily have to change hardware platforms. You could just upgrade it through the software, which is a nice feature. This is a picture of the back of my demo. 2 connectors on here. This is the Ethernet connection. It's an 8-pin M12. And then the power and I/O, which is 12-pin. There are a couple of breakout boards for easing the connection to the system. The PL101 was actually created for the Spot and for one of their other smart cameras called the BOA 2. The PL100 was created for their original smart camera, the BOA. This next slide might explain this a little bit better. The BOA can be powered through the Ethernet cable. It is not PoE, not true PoE where we would use a PoE injector. We call it passive PoE. The BOA Spot is 100 megabit Ethernet, but we have an 8-pin Ethernet cable on here. We only need 4 conductors for 100 meg. So there was 4 conductors that they weren't using, and if we use the PL100 board and we put power to the board, we can actually run 24 volts up 2 of those spare conductors and into the camera to power it. That comes in handy if this thing is, if you want to cut back on your wiring and you only want to send 1 wire out to the camera, we will use a PL100 because we can power this through the Ethernet cable. And normally when you're doing that scenario too, you're doing all of your pass-fail type parameters through Ethernet communications to the PLC. So you're just loading registers, you're reading registers from the PLC to maybe trigger the camera or change programs, and then you're loading registers in the PLC with pass-fail results. Or maybe even measurement data or things like that. We can even send strings. The PL101 would be used if you were going to use the discrete I/O on board. And so the Ethernet cable would just go to your LAN or your PC or whatever you're connecting it to. Power would go in over here, and of course we send power up the power and I/O cable. And this just gives you some nice screw terminal connections to access the I/O in here. And it also gives you an RS-232 port because the RS-232 comes out of the lamp connector. And this breaks it out to a 9-pin over here on the side for those of you who are still using RS-232. They use the M12 lenses. Again, it's a vision sensor, so it's characteristic by using M12 lenses. It's all in one box, and it has an integral LED light. The LED lights come in red, white, and blue. And for the, let me take a step back to the Banner eye view. They also come in multiple colors. They have red, white, blue. They also have infrared, and they have ultraviolet lighting on that product. This one's just the 3 colors. It does have a C-mount version lens. Of course, you do lose the light when you go to that scenario. And just to give you some pricing, the BOA Spot, $640, $480. SL, which would be the vision, and IDS, which would be the barcode reading version, it's $1,100. You can do a lot with this, with either one of those. So if you 64480 is going to be a resolution that you can use. Of course, you're going to have to buy a couple cables, which is going to add, maybe another $100 to this, but that's a pretty low intro price to get into the vision market with a product. And then, of course, the prices go up accordingly. The 1280 by 960s are a little more expensive, and of course, when you go to the higher end software package where you get all the tools, you'll get up around the $2,100 range, but still not bad. All right, that's the end of my PowerPoint. What I'm going to do now is I'm going to go in and show you an example using their emulator. And I don't need that. So let me go into my emulator, BOA Spot emulator configurator. I think I've already got this configured. I'm going to emulate the higher end software package in a 1280 camera. So I'll launch this. And let me just slow that down because that'll drive you crazy. And I'm going to reduce this picture a little bit so we can see a little bit better. What this is this was an application that came in a couple months ago. It's the top of a 55-gallon steel drum. And of course, they put this cap in here, or what they call a bung. And what they wanted to do is these things were coming down the line, and they needed us to report the center of this cap, the XY position of this, so that something could come over, grab onto it, and either screw it in or take it out. I think they were taking it out in this case. The problem was, as I go through these pictures, is that these caps had a large variance of what they could look like. And of course, you didn't know what the orientation was going to be on them. Some of them, had a feature in there. There's actually a cap there. It's just really dirty. There's a lot of oil and stuff on here, so it's very dark. And so as I go through these images, you can see that these caps have different features in them, which posed a little bit of a challenge. Vision likes to see things that are somewhat consistent. If you have variableness in there, you have to deal with that, and so that's what we had to do in this scenario. So as I looked at these pictures, as I went through them, as I was taking them, I noticed that there was something of the feature that kind of was consistent through all of these, and that's this octal pattern right here, which is a raised area on the top of this steel drum. And I noticed that it was somewhat consistent throughout my pictures, regardless of what this looked like. So I thought, okay, I can use that to my advantage. And so I'm going to build this application right now for you. And this will probably be the only example that I show you of this one, because that's going to take about 10 minutes or so. And I don't want to keep you here all day. I know you guys are busy and you have things to do. So let's start out by just going to the tools area. Before I step there, right now I'm in this setup area, and this is where I would set exposure times and strobe durations of the light and things like that. Of course, this is an emulator. These are all grayed out because, well, I'm looking at bitmaps that I saved from a real camera. And so now we go to the tools section, and the first thing I do is take a picture. And I'm going to move this around until I get a picture like that. That's I kind of want to get it into an area where it's in the middle. And so I need to locate this thing, because in order for me to find the center of this bung right here, I'm going to have to use one of these circular tools to really give me a good XY position. But since it's moving around, I need to go find the center of this, or find this circle area here. So I'm going to put a match tool. I'm going to draw a match tool on here. And this is going to be my teach box. And the outer one is my search region. So I'm going to search for this, because you saw it move around quite a bit in here. And so this is my teach or learn box. I'm going to stretch that out a little bit. And I'm going to open up the parameter dialog. Wrong one, sorry. And here's the pattern that I'm going to teach it. There's two algorithms inside their match tool. All pixels, which is really looking at grayscale, a lot of different grayscales in the different areas inside here. And then there's one edges only. I think the edges only works really well for a lot of scenarios because it's a very strong algorithm. And you can see we pull a lot of edges on there. Unfortunately, we've pulled a lot of edges out in here that are going to change quite a bit. Okay. And so as far as rotation, I'm going to put a rotation here of we'll say minus 45 to a plus 45. Just to compensate for any rotation as this thing comes around. Of course, this pattern repeats it repeats every 8 times on the 360. And so what I'm going to do here is I'm just going to say OK. And I want to go see how well this is going to work. So I'm going to go to run. And I want to start snapping some pictures. And my gut feeling is it's not going to work very well at all. But I could be wrong. Yep, see, that one failed. And it's because there's a lot of variableness going on in the center. I'm going to have to stretch my search box out a little bit too. And so I'm going to have to make some changes here. And so I'm going to go back into Tools. And the first thing I'm going to do is stretch out my search area a little bit more. I saw I was getting kind of close to the edge there. And I'm going to go back into this parameter dialog. And I'm going to go to some of the advanced features. And under the advanced feature, we have some masking that we can do. And so I'm going to stretch this out a little bit, just to make it easier for us to see. And I'm going to use, I'm going to get a brush size of about 20. And I'm going to take the stuff out of the middle, because I think that's what's really hurting me right now. So I'm just going to click and hold my left mouse button. I'm going to circle this thing around. And anything that's going to be underneath this red is going to be masked out. There, that's pretty good. Now I'm going to go to a much larger brush size. I'll go to a 50. And we'll paint the center of this thing so that we don't look at any of the edges or any of the grayscale information that we would normally see in here. And see if that improves whether or not we can pass or fail this thing. Because again, I'm only using this match tool as a locator. So now I've masked that out. Let's go back to run, and we'll take some pictures. And what I'm looking at over here on the left side of the screen, see this MS? That's the name of the tool. It was the default name for the match tool. I'm looking at this percentage, and I want to see how much it changes from image to image. It looks like 90, there's a 91. Of course, I'm way down here near the edge of this thing. It looks like I did a pretty good job there. Let me shrink this down just a little bit more. Go back to Tools. Stretch my search box out a little bit more. So that's working. So now I'm in Tools. Now I need to turn this match tool into a locator. So you see by default there's a center point of this Learn box. And so I'm going to go in there and I'm going to right click that center point, which is really a point property. And I'm going to say you're going to be locator number 1 position. And I'm going to say OK. And it puts that bullseye on there. Now what I'm going to do is I'm going to take this tool off the screen. I am going to leave the bullseye there because I'm just using that match tool as a locator. And so now I'm going to put another tool on here that is going to follow the locator that hopefully will give me a great XY position for me to report out of this camera to the device that's going to come over here and remove this bung. And so I'm going to pick the circle tool here. And I notice I got a nice circle in here. If I come in here and I'm going to click on 3 points on this circle, and I'm going to get a circle tool, and it's going to have a center point. Now I'm going to make this the match tool center point go away. And so this circle tool now is creating this point property right here, and it's called PP1. I'm going to go back into this circle tool, and I'm going to increase my spokes. There's only 10 spokes on this. I'm going to increase the spokes a little bit, hit apply, so I get a little better reading, get a little more accurate center point, and say OK. And so now on this center point, I'm going to go into the point properties, and I'm going to enable X. And I want to report X anywhere between 0. This is a 1280 camera, so I'll put 1280 over here. Lock it. And I want to report Y anywhere between 0 and it's 960 as the Y. Say OK. Say OK. And so now I'm going to report that XY position. And let's go see. Let's go to run. Let's see how it tracks. And we should see the XY position over here on the left side of the screen. So I'll take a picture, and there it is. And these are pixel locations. So it's 689 to 360. If I put my cursor, if you look right up here at the top, this will give X, Y, and intensity of the pixel at the tip of my pointer. So if I put my pointer right on that, it's at 688, 360, which is close, 689, 360.7. So it is reporting this position right here. As I go through these and it moves around, the match tool is locating the octal pattern, which places the circle tool over the area that I'm interested in. And regardless of how it changes in the middle, because we masked that out in the match tool, as this thing moves around, I can report that XY position regardless of what changes in the center of the thing. And just to show you one more feature here, I'm going to go in and I'm going to write just a small script so that I can report that XY much larger down here at the bottom of the screen. But really, it would be how I would report it over to a PLC register also. So I'm just going to go in here to the script editor. And of course, there's all kinds of functions in the script editor. There's all kinds of things that you can do. But what I'm going to do is I'm just going to create a variable called A. A equals, and I'm going to have X. Oops, sorry. This is going to be literal. So I'm going to have X space equals space, and then I'm going to put the data in there in string format, and so that's going to be I want px that px1, and of course there's some syntax things that we have to do. I'm going to do 3 integers with 1 decimal. It's going to be a float, and then I'm going to do a line feed and a carriage return, so that it looks better on the screen. And then I'm going to have y equals, and then we'll go ahead and put the syntax in there for the y position, which is going to be py1, and we'll do some syntax, 3 integers, 1 decimal place, float f, and we'll get rid of our literal statement. And I'm going to come down here, and there's a built-in function under System Miscellaneous, which is called Set Display Status. And of course, I've created a variable with all this float, with all this syntax in here called A. And so I'm just going to put my A there. Then I'm going to pick my color that I want my symbol to be here, or the XY data. And I'm just going to pick sky blue. And there's a number of them in here, and I just happen to know that's one of them. I'm going to check my syntax. I didn't get any errors. I'm going to say OK. I'm going to go to run. I'm going to push the trigger. And you can see down here I get X 689, Y 360, which is what we're seeing right here. And as I go through all of these, I was able to pull that out. Just imagine this data going via Ethernet over to your PLC and being put in a register so that you could feed it to a robot or whatever other type of device is actually going to go over there and take this bung out of this steel drum lid. All right, and that's my example for that. At this point, I'm going to conclude this. I appreciate your time today. If you guys have questions, Jeff's going to probably get back on board here, and he will let me know what type of questions we have, and we'll see if we can answer any of them. And again, before I finally get up, just appreciate everybody coming out today and taking a look at this. If you've got any questions, again, fire them in here now. Otherwise, you can certainly call into CNE Sales, ask for me, and we can talk one-on-one on anything that I've talked about here today. This is being recorded, and so you will have access to that later this afternoon on our website if you wanted to go through and review any of this stuff. So this time, I'll open it back up. Jeff, you up there?
I am. Tony, thanks. Nice job. We currently do not have any questions. We'll wait just a minute and see if anybody types any in. As Tony mentioned, if you have questions, you can enter those here on the box, but you can also either email him or contact him here at CNE at our 800 number, 800-228-2790, and he'd be happy to answer any questions. Tony does vision day in and day out every day. That's all he does. He doesn't have another discipline here at CNE. It's strictly vision. So, Tony, we did have a question come in. So what is the frame rate of the iView 2 Plus Gen 2 sensor?
The frame rate of that, I'd have to look it up to be exactly sure, but I'm fairly certain it's 35 frames per second.
Thank you.
And when you talk about frame rates and things like that, what's really important is your exposure time. If you've got a moving target, we have to keep the exposure time down, low enough so that we don't get a condition called pixel blur. And so that's really more important than frame rate on this, is how many images you can take, not just how many images you can take a second, how many clear images you can take when you have a high-speed target. These sensors, have a certain amount of speed to them. If you have a high-speed application, we certainly have other sensors with faster processors in them than the vision sensors. Vision sensors tend to hang out at the lower end of the price spectrum, and because of that, we're not putting the fastest processors in there. And so if you do have a speed situation, we look at it. And if we can't do it with a vision sensor, we can certainly just take one step up into the smart camera world and probably solve it that way.
Thank you. No additional questions have come in. As I mentioned, Tony's available to look at applications. He does a lot of proof of concept stuff back at his desk, where he's taking samples and lighting them and trying to figure out the best way to solve those applications. So he spends a lot of his time doing that kind of work if you need assistance in that area. So if you do, just contact your C&E salesperson and they can get Tony involved to help out. Tony, since we don't have any other questions, we'll go ahead and end the webinar now. Thank you again for a great time. Thank you everyone for attending. We appreciate you coming to the webinar, and please try to attend next month's webinar in July. It's July 13th, where Jay Swank will be talking about integrated safety with VFDs.